You're now listening to Alpha Leak, a podcast mini-series highlighting the most under-the-radar projects and developments in crypto. And this series is brought to you by the Blockcrunch podcast. I'm your host, Jason Choi. I'm a general partner at Spartan Capital and an active DeFi angel investor. Nothing on this show should be construed as financial advice, and my guests, myself, and my employer may hold positions in assets discussed on the show. And if you'd like for your project to be featured on this series, reach out to me on Twitter at Mr. Jason Choi. Now, if you've been in crypto for a while, you probably know that cross-chain is the next big thing. And I personally don't think that most users in crypto will be paying hundreds of dollars in gas fees just to use applications. And I believe that most applications in crypto will actually be built across multiple chains. And one of the projects that really convinced me of this view is LayerZero. And LayerZero is building a messaging protocol that allows applications to straddle across different blockchains. This means you cannot just send assets to different chains and go on yield farms. You can actually build applications that are using multiple chains at the same time. And this to me is the future of crypto development. So I'm really excited to have Bryan, the co-founder of LayerZero, to come on the show and describe to us just exactly how this will work. This episode is also brought to you by PARASWAP. Stick around to learn more. This episode is also sponsored by the HBAR Foundation. Hey everybody, I am super excited to have Bryan Pellegrino, the co-founder of LayerZero, finally on the show to talk to us about cross-chain. So Bryan, welcome to the show.
Thanks so much for having me.
Now, before we dive into this world of cross-chain and what LayerZero is, can you give us a little background about how you got into this space and what gets you excited about this space? Let's applications.
Yeah, I mean, ultimately, it just came from trying to build something. We were trying to build something that dealt across multiple chains. There's like no viable solution. There's nothing that was compelling and nothing that we would put any significant amount of TVL behind or kind of want to build on top of. So it really all just stemmed from that.
So at what point did you realize that building infrastructure for cross-chain is a big enough opportunity for you to spend all your time on?
Yeah, I mean, I think a lot of it comes from it just came from general scaling, right? So it started with just Ethereum, and Ethereum's amazing. Like we started having all of these really cool use cases being built on, and then it got like more and more popular and got more and more congested, and like fees went insane multiple times over multiple cycles. And so like everybody started to focus on layer 2 solutions, like specifically to scaling Ethereum and leveraging like Ethereum's security. But then we had all these really interesting layer ones, and that first layer ones maybe weren't that interesting. A lot of them were just like pure EVM forks with kind of slight derivations and kind of improvements, like iterative improvement or trade-offs. But then we got things that were, really genuinely interesting with the, Solanas and the Avalanches and these things that seem to have really kind of robust ecosystems that are growing more daily and interesting trade-offs on sort of the chain and how they handle different properties. And so I think that really is where, it's not a controversial thesis to say now, like, we're going to live in a multi-chain world. Like, I think it's becoming more and more obvious that is the way things are trending. We're going to have lots of layer ones. We're going to have layer twos. But I think, 12, 18 months ago, like that wasn't necessarily like, a compelling conviction compared to like, okay, maybe we'll have competing layer ones, but it wasn't like it, it's definitely happening. And it's definitely happening in a lot of different places. Yeah.
Yeah, I absolutely agree. It's pretty crazy to think that cross-chain was almost contrarian, 12 to 18 months ago, and now it's a consensus, and there's so many different projects tackling this. So we're going to kind of dive into that and try to understand what the lay of the land is in a bit. But as you brought up some of these names like Solana and Avalanche, many of them rely on different schools of thought when it comes to scaling. And some people believe in kind of monolithic chains, right? Like Solana, where you have one layer one and everything scales by hardware. And some believe in more sharded approaches like Ethereum with the layer 2 rollups and all that. So what assumptions do you have to make, or what beliefs do you have to hold for you to believe that a cross-chain future where there are multiple layer 1 ecosystems is the way to go?
So the way that I think about it, which may be different than most people, is I think about it similar to how I think about programming languages. So like when I go to build something, I don't think ahead of time and say like, I'm definitely going to build this in JavaScript, right? Like I think about what I'm actually trying to build, and you write the front end in React, and like you need speed. So you end up going down and you write pieces in C, and you need more speed, or you need like parallelization, and you go write CUDA code. Like, you know what I mean? There's different tools for different aspects of what you're trying to do in different parts of a system. And so, we have all of these things that are nice and atomic and live in a single contract on chain. But we're just able to add a lot more complexity now, and there's a lot of trade-offs. So I think about things as kind of the most interesting layer ones or layer twos are the ones that have kind of the most orthogonal sets of trade-offs. I think it's unlikely that the iterative steps are the ones that end up being the ultimate winners, but you have these large kind of disparity between what these chains are trying to accomplish, and that can be throughput, and that can be security, and that can be like, a lot of different things. But ultimately, I think applications are going to try to sort of capture pieces of that. So, this could be a game that, you look at Axie, right, where it has its own like Ronin chain, and you basically roll off like all the gameplay and all this high throughput, high action stuff into this chain that is able to support that extremely cheaply, and then you roll it back. Like basically any layer one these days is going to be able to kind of act like that, where you might have pieces of processing or piece of your application that you want to live there because it makes sense to do, but you want to resolve that, or you want it to live in another place that sort of has different sets of trade-offs. So I think about it more from that stance than anything else.
That is really interesting because in one of our prior conversations with another kind of cross-chain project, Connext, we're talking about blockchains as cities. And the way I think about cross-chain infrastructure is almost highways between cities. And even in my own experience today, most of the apps are still not completely cross-chain yet. It's more so where I send some asset to one chain, I do some stuff on that chain. Maybe a week later, I send the asset to another chain, I do some stuff on that chain. So in my mind, the activity that happens within the city is often much higher than the activity happening on the highways between the cities. So it sounds like you don't think that will be the future.
No, I don't, and we can kind of dive into this a little bit more. I mean, for now, for the moment, it will be. But again, I think most people approach a lot of this stuff from an individual user. And again, we can kind of dive into this as we talk about Stargate and LayerZero and some of these other things. But everybody thinks about it from a user. A user is going to come and he's going to bridge some assets from chain A to chain B, and like that's what's going to happen. But we think about it way more in terms of application. We think 95% of bridge volume is going to be driven by applications themselves, whether it's DEXs or all these other applications running across these various chains. We think applications are going to be the strongest driver of this, and users are going to live inside of those applications. And a lot of that stuff that's happening between is just going to be abstracted away from them. So almost everything we build through the lens of the applications building on top, whether it's security properties, whether it's trade-offs in terms of how they integrate. Almost everything is through that lens.
That's definitely a really interesting approach because obviously today apps are still pretty primitive and most of them don't live across chain. So I'd love to kind of understand your thesis behind that in a bit. But first, can you help us kind of understand what is the current state of cross-chain infrastructure? Because as users, I'm sure a lot of people are confused about the sheer number of bridges out there, right? Like every chain has its own bridge with Ethereum. Like, why are there so many bridges?
So I think like the inherent problem is you have these two chains that are atomic in state, right? They both know everything about their own chain and nothing about anything else outside. And you need to pass some information, some state share, some transfer, whatever it is, some message between them. And the way that almost everybody tries to solve this right now, 95% plus of solutions, is to just stick a chain in the middle of it. So we're going to throw in our own chain. It's a middle chain. And you're going to write a message from the source chain. You'll write a transaction. The middle chain is going to come to some sort of consensus as to the validity of that transaction. And then it is going to write a message out to the destination chain. And that's like a very, very important caveat, because what it means is that the destination chain is implicitly trusting whatever the middle chain says. The middle chain has complete signing authority over the destination chain. So if it's corrupted for even a matter of blocks, right, has the ability to just tap all liquidity on all paired networks basically instantly. And this is what you saw the Poly network hack and a bunch of these other things where the hacker was be able to make himself the only validator and just told the destination chains like, hey, all of that money belongs to this address, right? So it's like this central catastrophic kind of pool of risk. And I mean, securing layer ones are hard enough on its own. Even primary chains, right? Like you look at the reorgs that are happening across chains, like even fairly deep reorgs. Polygon, I think, is having like 60 to 150 block reorgs like every single week. Like this stuff is hard, even when you have all the right sort of aligned incentives to kind of secure these networks. So when you're talking about this middle chain that sits in the middle that has nothing building on top of it, it's just connecting applications across. Typically fairly weak security properties, like 10 to 30 validating nodes, maybe $200-300 million of bonded value, but it's meant to secure tens of billions of dollars across paired networks, while at the same time becoming more and more decentralized. It's just, in our opinion, a disaster waiting to happen. Right? It's just an unbelievably large honeypot. So this was kind of an approach that we didn't like from the beginning. We agreed from the beginning, like we would never take this approach. And so the only other really viable approach right now, and I'll say kind of viable in quotations, is kind of IBC style to run a light node on chains. You're going to take the entire block history from one chain. You're going to take every block's block header and write it to the other chain sequentially, and you're vice versa, right? So now you have the complete block history of the chains on the other ones. And once you have this, it's amazing, right? You can just submit the transaction, do the walk, and validate that the transaction is valid, and that's fantastic. But the problem is writes on blockchains are incredibly expensive, right? So to do this on Ethereum, you're talking like tens of millions of dollars per day per pairwise chain tied to Ethereum. It's just completely impractical from a cost perspective to implement right now with the way that things are. And so, we invented something we call an ultralight node. It's the process of streaming one single block on demand and validating that block in isolation. And so we do this. You basically need two parts to be able to validate a block. You need the block header and you need the transaction proof. So your block header contains the receipts root, and your transaction proof for an EVM is a Merkle-Patricia proof. Combine these, you can validate them on chain. And so we have two parties basically responsible for this. Your traditional Oracle, Chainlink, Band. This can be, Pyth, Super Oracles, all the other upcoming Oracles. Forward this block header, and then the relayer, which is an open permissionless system, forwards the transaction proof. Now, can kind of go on and on about how this functions, but it really reduces down to two interesting properties. The first is that the worst case security property of this configuration is equivalent to the best case security of the chosen Oracle. So if Chainlink is the Oracle that you, the user application, has selected, the very worst case is that your Oracle and your relayer are the exact same entity. They agree on everything. They're both the same. They're in collusion, whether malicious or not. And even in that case, it's still as secure as the Chainlink done, right? So worst case security is equivalent to the best case security of the chosen Oracle. But for every other case, that even if your Oracle has become malicious, worst catastrophic case, it's in collusion with relayer A, they're performing an attack. In this case, only applications accepting messages from exactly that Oracle and relayer A are affected. So anybody using relayer B through Z, anybody relaying their own transactions, anybody using any of the other oracles, completely unaffected. So what you've done is taken this attack vector of, hey, if you break this system, if you break this middle chain, you win everything, to, hey, even if you defeat the oracle, you win a tiny, tiny sliver of risk. So now that cost has become exponentially higher, orders of magnitude more expensive to execute in a meaningful way. And that's just an extremely attractive security property to have when you're talking about these kind of systems.
Absolutely. And I'd love to dive deeper into that, but I'd also love to kind of take a step back to make sure listeners who are from a less technical background understand where LayerZero's ultralight node fits in the context of all these other solutions. So you mentioned kind of three major types of solutions when it comes to cross-chain bridges today. There's the middle chains, or these beacon chains run by 20 to 30 nodes. And it seems like most of the cross-chain bridges today are middle chains, despite the very well-documented issues with them. So why is there this inertia? Like, why aren't more teams exploring on-chain light nodes or ultralight nodes? Why is most of these the chains, still middle chains?
Yeah. One, I think it's maybe the easiest to implement. It's very clear how you would drive value to a token in those senses, just like an easy structure. We're going to throw in our own chain. Of course, this chain has value because it's now a hub and spoke model, and we're going to connect to the world, right? So, like, from trying to sell a solution, that's a very intuitive sell. In terms of the light node, it's sheer cost, right? So across Tendermint chains, fine. Across like extremely cheap chains, this is something that's basically being worked on now or being implemented now. But you just can't do it to Ethereum. And the fact of the matter is that, like, okay, there's some other chains now, right? We're getting activity across other chains, but the bulk of the ecosystem still lives on Ethereum. Like, that is the main driver of most of this value in the current state of things. And then the ultralight node is something that we invented. So, like, yeah, nobody else is doing it yet because we released a paper on it like a month ago. So, maybe we'll see people play with that, but that's the reason is, that's something novel that we invented.
Absolutely. And because it is such a novel idea, I want to make sure our listeners understand how it works. So can you walk us through, when a message passes from one chain to another through LayerZero's ultralight nodes, what exactly happens? Can you kind of walk us through step by step?
Yep. So you have so Again, core function of LayerZero, connect every contract on every chain to every contract on every other chain. So you have a contract on chain A, and it's going to trigger some action or do some kind of communication with a contract on chain B. So what happens is you sign it, some transaction happens on chain A. That basically triggers the oracle to pass the block header. The user application has specified we're going to wait X number of blocks. So X number of blocks goes by, the block header is submitted to the destination chain. The relayer then, so that emits an event, the relayer submits the transaction proof. Now the destination chain has both of those things. It has a block header that has come from an independent oracle, and it has a transaction proof that has come from a relayer that was specified by the user application. Now that the destination chain has those two things, that validation happens directly on chain. There's no off-chain consensus being formed. There's no off-chain validation. This happens on the destination chain. Those things are validated. Assuming that message is valid, then that is passed on to the destination contract. So that's maybe more technical than you're kind of looking for, but in general, a transaction signed on the source, or you do some transaction, and that's going to trigger some contract or something on the other side. So like an easy way to think about this is you're building a DEX, you deposit, you put some asset into chain A and you get some asset out on chain B. And those two contracts would be like the one that you put in and the one that you take out of.
Now, before I continue, I'd love to share one of my favorite products in crypto with you. Now, whenever I want to trade a token, instead of going to Uniswap, SushiSwap, Bancor one by one to see where I can find the best quote, I just go to PARASWAP to scan for the best price anywhere. Because PARASWAP aggregates all the popular Ethereum dexes and saves me a ton of time and headache in finding where I can trade something for the best price, and lets me trade in one place. Now, the cool thing is they've also integrated with Ledger Live as well, meaning I can now swap at the best prices directly from my Ledger wallet. So seriously, if you're a DeFi trader and you're worried about the security risks of centralized exchanges, but you also don't want to scour dozens of dexes just to find the best price, you have to check out PARASWAP. So head on over to paraswap.io/blockcrunch. I'd also love to take a moment to talk about the HBAR Foundation. Now, if you approached me 1 to 2 years ago, I would tell you I'm really skeptical of layer 1 systems outside of Ethereum. But in the past 12 months, I started to notice billions of dollars and hundreds of thousands of users flocking to new blockchains left and right. And then I realized there's an actual market gap being filled. And I always love to support projects who support builders. And one of those projects is Hedera Hashgraph. Hedera is an enterprise-grade public network with its own crypto asset called HBAR. And the HBAR Foundation has launched with an initial budget of over $2 billion to provide entrepreneurs with the funding and ecosystem support needed to quickly build and deploy new applications on the Hedera Hashgraph network. The HBAR Foundation is eager to find builders in DeFi, NFTs, gaming, sustainability, and all sectors. So if you are a builder, a developer, or a creator with an idea, visit hbarfoundation.org to learn more. I'd love to talk a little bit about Notional. If you followed the show for long enough, you know I'm pretty excited about fixed-rate products. Notional.finance is the leading fixed-rate borrowing and lending protocol, and they've just released a major upgrade. With Notional, you can not only borrow and lend at fixed rates for up to 1 year now, but liquidity providers also have a pretty good opportunity. Thanks to an integration with Compound and a liquidity mining program, LPs can actually earn interest, liquidity fees, and token liquidity mining incentives as well. We've talked with Teddy from Notional recently, and as a happy investor as well, I've been pretty impressed with how the team is building this critical infrastructure that will help onboard the next billion users to DeFi. So you can check it out today at notional.finance/blockcrunch. And how are these relayers on LayerZero different from, say, relayers or validators on middle chain bridges like the Polygon bridge?
Yeah, it's a great question. So most of these other relayer systems are validators, right? More than relayers. So they're validators in that they're forming consensus. They're coming to some kind of consensus as to this being a valid transaction or whatever that may be. And if you can corrupt that consensus, then you get to just tell the chain like, hey, this is definitely valid, right? In our case, a relayer it's a little bit of an abstract term in that the relayer is fulfilling a job. Its job is to take a transaction proof out of a full node and submit that to the destination chain. And that can be implemented in a bunch of different ways. That can be implemented as a network of nodes who are kind of agreeing on what's being passed. It can be implemented as single items. It can be implemented as like a 1-inch style aggregator where it's sort of querying relayers for best price. So we've left this open in the same way that our Oracle implementation is actually left open as well. So if you want to do like 2 out of 3 Oracle consensus, if you want to not just rely on a single Oracle, like those are things that you can do. People can build this quite easily. The important thing for us is that the user application has all of these levers, because at the end of the day, the one absorbing the risk of any messaging protocol is that user application. If you have $500 million of TVL in your application and you're doing this cross chain, if that message is corrupted, like it's your TVL that's at risk, it's your users. So we allow them to specify their Oracle, their relayer, and the number of block confirmations they're waiting. So they want to bypass a challenge period or a roll-up period, then fine, they can bypass it. That's on them. Totally fine. They have that lever. If they want to wait 10 blocks instead of 35 blocks or X blocks, like fine, they can do that. There are defaults, but all of that is configurable. And then the most important thing, you're Aave, you're some huge protocol with like $20 billion of liquidity. You can run your own relayer, and as long as you're not colluding with the Oracle against yourself, you have complete control over the security of your transaction. As long as you're forwarding honest transaction proofs, or at least not maliciously colluding with another party, there is nothing that can happen to your TVL ever. Like even if the Oracle is completely malicious, you're just going to your honest transaction proofs and their dishonest block headers will just fail to validate on the destination chain.
That's really interesting. And speaking of specific implementations of the LayerZero protocol, you guys are also building something called Stargate. I don't think a lot has been released in terms of the details, so I don't know how much you're comfortable with sharing on the show, but would love to learn more about just what Stargate is and what will users be able to do on Stargate.
Yeah. So, when you think about LayerZero, when we think about LayerZero is generic messaging, right? LayerZero, that's all. It's not a bridge. It's not a DEX. It's not a lending protocol. Like these are things that are built on top of LayerZero. LayerZero allows you to pass messages back and forth between chains and trigger contracts. But what we realized is that in getting integrations to happen, in getting adoption of DeFi more broadly, let's talk about a DEX. If you're going to create a DEX cross-chain, there's like the really naive way you might do this is you're going to have one pool of ETH on Ethereum and one pool of SOL on Solana, and that becomes like your ETH-SOL LP pair. And you're going to, maybe you add to the ETH, you send a transaction over. When it lands, you execute XY equals K. There's a bunch of problems here. Like DEXs don't support single-sided liquidity pools. So they need to make a core protocol change. They need to incentivize these pools. They'll need to do ETH SOL, ETH Matic, ETH AVAX, recreate all of these LP pairs effectively in separate individual-sided pools, which is a huge amount of liquidity. And you only have one way. Again, because XY equals K needs to process sequentially, only one way can be instant or can be like a one directional. The other one will need to go out and also have an axe. So you have one side that sort of like is a lesser side of transacting. So this is like a huge lift for trying to get this integration. So another way they might approach this is like, okay, we're going to use some kind of bridging asset in the middle. Let's say it's USDC or it's MIM or whatever it is, right? So you're going to have pools of USDC. Same thing, single-sided liquidity on both sides. They need to incentivize those USDC pools, but now they can do like a swap from ETH to USDC. They can bridge the USDC and they can do a swap from USDC to SOL, right? Because like there's already an ETH USDC pair and there's already a SOL USDC pair. So now they can connect those without recreating these LP pairs. They only need to do the USDC. The problem is like, say Sushi does this. Well, Uniswap also needs to do it, and QuickSwap and Trader Joe and like all the yield aggregators and like everybody who's trying to do anything here needs to recreate this layer, which again is just like a huge amount of capital that's required. And so what we said is we're going to create this liquidity transfer layer that's all it does. It's a bridge. It takes 100% in native assets. There's a bunch of cool properties if you go read about it. It's 100% in unified liquidity. So rather than using all these pairwide structures, you have one pool of, let's say, USDC on Ethereum shared between all chains. LPs get fees across all chains. It has this property of instant guaranteed finality, which makes it 100% composable. But what this means is that now if your Sushis, your Uniswaps, whoever want to integrate with this, they can now do bridge swap over Stargate to any asset. So, and they can do that with taking zero protocol changes and zero risk to their LP. And that's like really important. So what would happen here is, Sushi swap on chain A gets an ETH, spits out USDC. That USDC is bridged over Stargate. And then Sushi swap on chain B gets an USDC and spits out whatever asset you're going to, right? And so by doing this, all of the risk, both of those, getting ETH, spitting out USDC on chain A, that's exactly how Sushi works now. There's no, that's just, it gets an ETH, spits out USDC. That's just a regular swap in their protocol as it is now, no changes. On the destination chain, getting in USDC, spitting out X, that's exactly how it works right now. Zero change to their protocol. all of the risk is in moving that USDC, all of the messaging risk, and that's completely housed by Stargate. Stargate is the one that takes that risk. And what this means is now integrations to any of these DEXs are now just a simple pull request. It's just integrate into your UI. You don't need to write any code. You don't need to make any changes. Anybody who's a third party who wants to wrap these applications across DeFi, you want to go from Sushi to Radium, done. You want to go from Uniswap on Ethereum to 1inch on Polygon, done. Anybody can make these third party kind of DeFi portals to connect all of these applications, all of these pathways. It's completely open. And the other thing is that, and this is really important, right now, again, you're trying to do this simple process of swap, bridge, swap, right? That's how you go across any of these, as you're moving assets across chains, you're trying to go to these things. And right now, if you're Sushi, you're going to swap. The user is going to leave your flow, is going to go to some external bridge. They're going to bridge the asset. They're going to have to get the destination gas in their wallet, claim that transaction, and then go and swap. And then they'll, they're not even getting real asset over there. They're getting some synthetic wrapped asset from whatever bridge they're using. And then they're going to have to take that, swap it out, and then, maybe they'll swap to whatever they really want. And so with this, you can stay 100% in the Sushi UI. It's a single click, and it's going to execute that entire flow. One click, paying only gas on the source chain. So you pay all of the gas upfront. If you're on Ethereum, you pay it all in ETH. If you're on Solana, you pay it all in Sol. You don't need that destination asset, and you're getting a real asset. You're not getting some wrapped asset. You're not getting anything. So you want to go from ETH on Ethereum to Sol on Solana, or ETH on Ethereum to, X on whatever chain. You just get that gas asset immediately dropped into your wallet, and you can go and transact there right away. There's no going out to some centralized exchange and sending yourself gas, and now I'm able to kind of claim or unwrap. So these are like really big shifts in how things exist now. And this is what I'm talking about when I talk about we've designed for the user application more than the individual, right? So this is meant to be completely composable and extremely easy for anybody to integrate over.
Yeah, and this definitely sounds like a step function improvement over what is currently available, especially with a lot of the synthetic approaches where you're not really getting the real asset on the destination chain. So are there any trade-offs? Are there any catch here? What are people kind of trading off when they use LayerZero versus some of the existing kind of synthetic bridges?
Yeah, so the thing you have with synthetic bridges, and again, we just released this Medium post on kind of like the bridging trilemma, which explains kind of the trade-off, and then Stargate really accomplishes all of this. But the one thing is with native assets, you need actual pools of liquidity, right? So if you have USDC on 4 different chains, you need real pools of USDC on those 4 chains. With synthetic assets, so let's say you have 20 million on ETH and 20 million on Solana, and somebody deposits 10 million on ETH, takes out 10 million on Solana. Like that pool can get drained. Now there's I won't go too deep into it, but Stargate has kind of curve style pricing at the bounds. There's all these incentives for keeping these pools balanced, and they should stay deep and liquid and balanced. But in general, like that's basically the issue when you're going with native assets is you need to have real pools of liquidity. When you're using a synthetic, you deposit USDC on one chain, and you get like any USDC or NUSD or whatever it is, some synthetic on the other chain, but they can mint that. They have full control to mint that. So that's basically the trade-off is you only add liquidity on one, and they'll just mint you a synthetic liquidity on the other. But the downside is a couple things. One, like try bridging USDC over Wormhole, right? From Solana to Ethereum. You land on Ethereum with like Wormhole USDC, which has no pairs anywhere, and there's like nothing. Like the thing that you can do is like bridge back and say, oh, that was a mistake. And there's a lot of this where like these synthetics are just really tough. But the other thing, like obviously when the user lands with a synthetic, they need to swap. But from the actual native application level, it didn't matter before because nobody was multi-chain. No one was deployed on all these things. It was just like, okay, we have some asset here. Like, let's make this version over there so we can kind of use it. But now you have these Curve, Aave, MIM, all natively deploying their tokens on a bunch of chains. If you're MIM and you deploy natively like $10 million on Avalanche, right, of MIM, but then somebody bridges like $30 million from Ethereum to Avalanche over any swap, like, okay, now that's like any MIM. That's a different MIM than your MIM. And then like if there's 4 bridges, there's 4 different versions of your token. They all need liquidity, like which gets put into the liquidity pools, which gets added to lending protocols. And then on top of that, if you have any functionality in your token, all of these wrapped synthetics are just a wrapped vanilla ERC20. Like you're a rebasing token, oh, good luck, can't do it anymore. Like, all of that is just impossible. Where if you actually have the native token, you retain all of these properties that the token is meant to have. So yeah, you the trade-off is you actually need liquidity like you do in anything else. But I think the benefit is like by far worth it.
Yeah, I feel extremely vindicated because even with my own team at Spartan, we always disagree on, is the future more about synthetics or is it kind of native assets? And I'm always of the native asset camp because, in my mind, if I bridge like Arweave token over with wrapped Arweave, I can't pay for storage. But then some of our teammates think that, well, synthetics actually account for most of the use cases today because trading is the largest use case today. So it sounds like you and I are kind of in that same camp where we think native assets make a lot more sense. Is that right?
Yeah, I mean, I'm a firm believer that in terms of use case, native assets like that is what. If I'm an application deploying on a bunch of different chains, I don't want to be reliant on some bridges version of my token, right? I want to have my own token that's deployed there, and I want to have control over it. I want to have it's that's what you're trying to integrate in these things because you have all these cool things that you can do with it and you can build into it. And if there's another bridge, so now all of your liquidity that you've integrated is like with this bridges version, but like a new cool bridge comes out and like, okay, well, now you've got to go through and like push for integrations with this new bridges token because everyone's using that. It was just a nightmare. So yeah, synthetics right now, like, okay, we have only ETH on Ethereum. Like we want WETH on all these chains because like we want WETH pairs and like you want to have, there's a strong reason for that. But as applications more and more natively deploy, like that's going to go away. Like that's just not going to be nearly as useful. It is useful for like gas tokens, right? Because there is no contract that's just going to mint you real ETH on the other chain or mint you real X. But in an application layer, they own those contracts and they control those and they want them to like interact with each other. And so I think it becomes a lot more viable.
Absolutely. And beyond just kind of cross-chain trading protocols, can you maybe give us some examples of what developers will be able to build with LayerZero when it comes to cross-chain apps?
Yep, 100%. So, we've already talked about bridges, right? Stargate is a bridge. We've talked about DEXs. You look at lending protocols right now, like money markets, right? Like the typical process is I'm going to collateralize ETH on Ethereum and Aave or Compound or whatever. I'm going to collateralize ETH on Ethereum. I'm going to borrow. I'm going to bridge, which is a fee. I'm going to swap to the asset on the destination chain I want, which is a fee. Then I'll farm or do whatever opportunity, and then I'll swap back, and then I'll bridge back, and then I'll repay my loan, and then I'll like take back my collateral, right? So like, and this is all on the user. This is all through a bunch of different interfaces where like you're using a lending protocol, you're using a bridge, you're using a DEX, you're using a farm. Like, it's just a nightmare at the user. With this case, over LayerZero, right? You could collateralize ETH on Ethereum, send a generic message to the destination chain and say, hey, confirm the collateral. You can issue the borrow in native asset. You now borrow on the destination chain directly in native asset, farm, repay there, message comes back, collateral is unlocked. So that's just like, 4 sets of bridging and swapping, completely done, entirely different user experience. When you're talking about unified governance, right? Like Sushi deployed across 13 chains, I think it is right now. But you can't swap Sushi to Sushi across any of those chains. None of the governance is shared, right? There's not like, so again, as these applications are deploying more, like unified governance is something that has to happen. And that's some stuff that we just didn't expect at all. NFT and gaming have been like a huge amount of inbound interest of wanting to be able to, again, move pieces across chains. So you want to do some set of your game on Solana or on whatever, some high throughput thing where you're like doing all these actions and you have, 1,000 transactions you're going to do in 100 hours and you're going to earn something, but like you might want to resolve that back into like a marketplace on Ethereum or, whatever that might be. There's a bunch of interest for doing this across multiple chains or having these applications co-running across multiple chains. And then we've even seen stuff like in kind of bridging traditional world, which I won't dive into too much right now, but the inbound interest has been staggering, right? You never know what it's going to be. We built something completely in stealth, and it just like came out and announced it out of nowhere, and you never really know like how that's going to go. And it's just been an unbelievable ride over the last 8 weeks. The interest has been unbelievable. It's really crazy.
Yeah, and even in those few examples you brought up, right? Like collateral on one chain, loan on the other chain, unified governance, NFT and gaming, bridging traditional financial assets. Most of these things have not been built yet. So in my mind, I think the renaissance of cross-chain applications is just beginning. And I know there's a lot of people out there that are kind of disillusioned about DeFi and how much it's slowed down ever since Uniswap and it was launched and compounded their farming thing. And it doesn't seem like there's any new innovation, but I do think the next threshold, the next frontier seems to be these cross-chain applications and not just sending coins across chains, but applications that actually have utility on multiple chains at the same time. I think that that's going to be extremely exciting and extremely interesting. Now, on that note, when developers use LayerZero and Stargate, what would you say are the biggest security assumptions that they have to make in their mind to be comfortable with using LayerZero?
Yep. Yeah. So, I mean, using LayerZero at its core, like you are any messaging protocol, it doesn't matter what you're using. Like the construct of the messaging protocol is you're signing some message on chain A, and somehow that message is going to get delivered to chain B, right? So we've built what we believe is kind of like the most trust minimized solution that you can possibly have right now. And again, if you are worried about that aspect of it and run your own relayer, you have complete control over that. But that the assumption that you're taking on is that the oracle and the relayer are not in active malicious collusion. And there is a bunch of economic structure around why this is very unlikely to be the case. You have the ability to run your own relayer. There are all of these things that kind of like prevent that, but that is the ultimate solution, is that your oracle and your relayer are not in active malicious collusion against your application. Yeah. So in terms of building on that, in terms of Stargate, the nice thing is that all of that again is completely abstracted away from you. Now you have this, what we call kind of this key composable DeFi Lego, where you have this value transfer piece built in between. And so now if you're if you're doing like yield optimization across different chains, if you're a DEX, if you're any of this, now you can integrate and you can do this entire flow without taking any of that liquidity risk, right? Because you're just leveraging Stargate, where it's the one who's moving the asset between. And that's just like a huge step forward over what anything else that has been prior. So yeah.
Absolutely, and I think this is probably a great note to kind of end the interview on as well. Given how much we've gone through, I'm sure there's a lot for our listeners to digest here. So in terms of people who want to reach out and build on top of LayerZero or want to learn more about the product, what are the best channels for them to do this?
Yeah, Telegram, Discord, Twitter. Although I think we only have 2 tweets right now, so we're working on it. We'll step up the communication side, but we're super active in both Discord and Telegram. You'll find me in there at 4 a.m. on any given night, kind of answering questions of whoever has them. So we love people who are trying to build.
Definitely, I'll definitely add those links in the show below. And Bryan, I think one of the things that we take pride of in the show is how early we are able to kind of share the next big thing with listeners out there. We talked about Solana back in 2018. So I do think that this is going to be the next big thing. So listeners out there, definitely check out the blog post that we're going to be putting in the show notes below and reach out to Bryan and learn more. Thanks for coming on the show.
Thanks so much for having me.